Hello students. Today we are going to see Kolbe's electrolysis. You heard about the Kolbe electrolysis, I think. I think you have learned how to prepare the alkane from Kolbe electrolysis, right? Actually, we can even prepare the alkene as well as alkyne also from Kolbe electrolysis. I'm going to give the clear interpretation about the Kolbe's electrolysis in this video. Let us see how to prepare that alkane first. So for that preparation of alkane, we have to take carboxylic acid. Carboxylic acid may also be the starting material, or sodium salt of carboxylic acid may also be the starting material, that is substrate for the preparation of alkane. Let us see one by one. So first of all, I'm going to take the carboxylic acid. I'm going to prepare that alkane from the carboxylic acid, CH3COOH. Usually in from the 11th standard and 12th, from 11th standard you should not write the carboxylic acid like this. I will give you, actually this interpretation will give you idea about the reactivity of carbonyl center. So please represent the carboxylic acid in this manner, and then when we are having acid, we have to prepare that. That is, here we are giving that called electrolysis, right? Electrolysis needs electrolyte. So we have to convert this CH3COOH as an electrolyte. But you can ask, ma'am, CH3COOH itself is an electrolyte. Then why I should convert that into electrolyte? Actually, it's a weak electrolyte. So to get that proper yield, we are going to make it as a strong electrolyte by adding sodium hydroxide or potassium hydroxide. Then we will get the corresponding salt, right? So the corresponding salt will be CH3C double bond O, O, Na. This will be the corresponding salt. Now we are having the strong electrolyte, that is salt, sodium salt of acetic acid. So sometimes sodium salt of acetic acid can be used directly in the Kolbe's electrolysis. Don't bother about that. You can take either acid or you can convert that into, that is, you can take either the sodium salt of carboxylic acid. The purpose is we have to make that as a strong electrolyte. Then the electrolyte only will be dissociated into positive and negative part. Then you can ask, ma'am, why I need the positive and negative part? Because we are going to do the electrolysis here. For the preparation of alkane, we are going to do the electrolysis. So CH3COO minus and Na plus will be there. We are doing electrolysis. What is the meaning for electrolysis? We are passing current. That is, we are going to give the electrical energy to separate this one into anode compartment and cathode compartment. I think anode. Why the name we are getting anode? Because it will attract anion. So I'm going to take that anion in this part. Anion is the species which is having the negative charge. So anode will attract that negative charge species, that is anion. And then here it should attract the negative charge species, right? That's why it should possess the positive charge. Then only, that is, you have to connect that anode compartment to the positive terminal, or otherwise you can take like that. The positive compartment, that is the positive electrode, act as a anode and the negative electrode act as a cathode. So cathode can attract cation. Here Na plus will be the cation. And here one more thing, we are doing the electrolysis in the aqueous solution. So aqueous solution is having water. So water can also do the electrolysis. When you are passing current, it will be dissociated into H plus and OH minus. So there are two type of anion and two type of cations are there in the Kolbe electrolysis compartment, that is Kolbe electrolysis process. So in this case, anode compartment is having two kind of anion. Among that, CH3COO minus will get oxidized easily than OH minus. So this can oxidize easily. Why the oxidation is happening? Because it is connected with anode. Anode needs an electron because it's a positive charge, right? So it will take the electron from the anion. That's why there will be an oxidation. And here there will be a reduction. So reduction, we will compare one by one. First thing, in the anode, we are going to give the oxidation. That is, oxidation is going to happen. That's why CH3C double bond O and O minus will lose its electron. So after losing its electron, it will be converted into CH3C double bond O single electron. Here the minus charge indicates there are two electrons, but here it loses one electron because it is connected with anode. Anode, there will be an oxidation happen. That's why the electron will be lost. Loss of electron will be called as oxidation. And then what will happen? This one electron, this there will be a homolytic cleavage at this part. One electron will move towards this place, and this electron will move towards this place, and both the electron will make a bond here, and then one more electron will come back here, and then we will get the methyl radical, methyl free radical we will get. So Kolbe electrolysis is a ionic mechanism as well as free radical mechanism. Because ionic mechanism, how I am saying that ionic mechanism, because positive and negative part are electrolyzed, that's why. That is a electro it we are taking electrolyte and it will be dissociated into positive and negative part. So ionic mechanism is also there, and as well as free radical mechanism is also there. So finally we are getting the carbon dioxide and then CH3 dot radical. If you have taken two molecule of acetic acid, then you will get the two methyl radical, and two methyl radical combined together, and there will be a formation of CH3CH3. Hope you have cleared about this one. So in anode compartment there will be the release of CO2 gas. Here among these two, which one? This one as well as this one. There are two kind of anion. Among that, one will be reactive. That is, one will get easily oxidized comparing with another anion. But in this case, hydrogen is more reactive than sodium is more reactive than hydrogen. So hydrogen only will reduce, because sodium don't want to get reduced, because it will be a reactive one. It wants to be always in the plus state. That's why H plus is getting reduced in the cathode compartment, because H plus is less reactive. That's why it will attract the electron that is released in the anode compartment, and then it will be converted into hydrogen gas. So in the cathode compartment, there will be a releasing of hydrogen gas. In the anode compartment, there will be a releasing of CO2 gas as well as hydrocarbon. Corresponding hydrocarbon will also be released. And one more thing, you should be very clear on this point. Actually, Na plus and OH minus parts are remaining in the solution, right? Na plus and OH minus. So the solution get basic. We are having the pH greater than 7 in the solution compartment, because Na plus and OH minus remaining as such. Hope you have understood that point. And the next second thing, we are going to prepare alkene we are going to prepare. Again, here also we should take the carboxylic acid, but here we should take that dicarboxylic acid. Actually, I'm going to take that succinic acid. You can say, ma'am, why you are not taking oxalic acid? Oxalic acid will release the carbon dioxide. You could not get any alkene. That's why to get that alkene itself, minimum I need 4 carbon atom. So minimum I need 4 carbon atom, and two should be converted into, two of the carbon atom should be converted into carboxylic acid. That's why I am going to select succinic acid. Shall we? Yeah, succinic acid is nothing but the 4-member dicarboxylic acid. So dicarboxylic acid I am just taking like this, and then convert that into corresponding sodium salt or potassium salt. In the last part, I have taken the sodium salt, because why I'm changing that again and again, you have to realize we can take anything. That is, we can take anything, any base, to convert that corresponding carboxylic acid into the strong electrolyte. So that's why I have taken the KOH, and now we are getting the potassium salt, CH3C double bond O, and then K plus. And then here also CH2 C double bond O minus and K plus. So here the strong electrolytes is electrolyte we have prepared, and then we are going to electrolyze that one. When you are electrolyzing, there will be an anode compartment and a cathode compartment. In the anode compartment, we will have CH2 C double bond O minus, and then CH2 C double bond O minus. In the anode compartment, we are having this anion, and cathode compartment we are having K plus as well as H plus, and here also we are having OH minus. And then you know that that is OH minus will not get oxidized. Our carboxylic acid part only get oxidized. That's why I'm going to oxidize that carboxylic acid part, that is CH2C double bond O O minus, and then CH2 C double bond O minus. First it will be converted into the corresponding acetate radical, sorry, corresponding carboxylic acid radical. So carboxylate radical I am getting, and then one electron will come here, one electron will come here, and then here also one electron will come, and then where there will be a releasing of CO2 and the corresponding CH2 red dot and CH2 dot will be there, and then when it is forming a bond, you will get the corresponding alkene. As usual, in the cathode, there will be a releasing of hydrogen because in the anode, there will be oxidation. In the cathode, there will be a reduction. In the reduction category, K plus could not react because reduce, because K plus will be more reactive than H plus. So H plus only gets reduced, and then we are preparing that corresponding alkane in the anode compartment. Hope you know that. Okay, and then we will go for that alkyne preparation. In the case of alkyne preparation, I'm going to take once again the dicarboxylic acid, but with double bond I'm going to take. So alkyne preparation from Kolbe electrolysis. So Kolbe electrolysis is not only for that alkane preparation. I think in your board exam you have heard about that alkane only. Okay, students. Okay. Now I have directly taken that potassium salt of maleic acid. This is actually the maleic acid and potassium salt of maleic acid I have taken. Potassium salt of maleic acid. So when you are electrolyzing this one, you will get definitely anode and cathode compartment. In anode compartment, we will get the corresponding anion CH C double bond O minus, and then double bond CH C double bond O minus. And here one more particle that will be OH minus. And then in the cathode compartment, there will be a reduction, and cathode compartment, there will be two kind of cation, and then further gets reduced, and only the H plus is getting reduced, and then H2 will be released. And in this case, this one, that is our anion, that is corresponding carboxylic acid anion, will be converted into carbon dioxide, and then you will have that compound like this. I think you understood that one. Okay, now let us come to the point here. What are the questions that has been related to that Kolbe electrolysis? I will explain that. So first thing they can ask, which gas will be released? Which gas at cathode? They can ask. Which gas at cathode? Cathode, there will be a hydrogen gas. In the anode compartment, there will be a carbon dioxide gas. If our alkene is gas, for example, ethane is a gas, so you can get the ethane also. For example, only I am giving. You can get that some butane also. Butane is also a gaseous form. So more than butane, we could not get in the gaseous form. Sometimes there may be a liquid. Then you should be very careful. In the anode compartment, definitely carbon dioxide will be released. And then if the hydrocarbon is in the gaseous state, then you can take that also. And the solution becomes basic. So they may ask, what is the pH of this remaining solution? pH of the remaining solution will have a basic condition. So basic. So it will be always pH of this, after electrolysis, the pH of the solution will be greater than 7. After electrolysis, you should be very careful. And then one more thing, we can prepare only the even number of hydrocarbon. So only the even number of hydrocarbon we will get. Odd number of hydrocarbon should not be prepared, could not be prepared in that case, could not be prepared in the case of Kolbe electrolysis. So that kind of things they can ask. And they can ask some other thing also, why the hydrogen is getting reduced instead of that sodium plus. So we can have that is we can have the answer like this, the sodium plus, that is sodium is higher reactivity, sodium is having higher reactivity than hydrogen, that's why hydrogen is getting reduced. So the less reactive one get easily reduced. Remember that less reactive one will get easily reduced because it don't want to react, that is it don't want to be there in the oxidation state at all, because it is not reactive, it wants to be there in the elemental state itself. That's why the less reactive one will get easily reduced. And the pH becomes greater than 7 because the solution is having the OH minus concentration. Whenever there is a OH minus concentration, definitely there will be a basic condition. You know that. And even number of hydrocarbon only we can prepare in the case of alkane. Students, we are going to start online courses on November 1, and there will be maths, physics, biology, chemistry sessions. It can be either one on one or group session as per your choice. This is for class 11th and 12th current year students because we are having JE exam in our January, right? That's why we are going to keep the session for everyone from now, November 1. And then if you are having any doubt regarding that session, you please give a text to my WhatsApp number 7010802531. Thank you, students.